Okay, grade 10s, you're going to investigate the effect of tension on wave speed in a guitar string with this wonderful simulation here for you. You should first complete the variables, then you should do the research question, and then do the hypothesis like we practiced in the previous task. Right now, you're on step 2. Watch how to use this simulation. First thing, you're going to load it up. I already have it here. Choose which string to investigate and record its string number and its linear density. So you choose whatever string you want. It's your choice. You can come in here to kind of see. And some strings might be faster or slower depending on their linear density and also their tension. I'm going to click up here. So let's say I choose string 4 for some reason. I can choose string 4. Then I go up here and string 4, the tension right now is 25 newtons. And every time I click this number 4, it randomly gives me a new tension. So there's no control of that, it just randomly gives it to you. You're going to be doing a total of 8 different tensions. So let's say I start here with 89 newtons. I click return. I click on this part, and it tells me I need to press a stop button when the front of the wave is at the 25 centimeter mark. So I press number 4 because I chose wave 4, and I press stop. And as long as I am within 1 centimeter, so between 24 and 26 centimeters, that is okay. So I need to, we're going to accept this as 25 centimeters plus or minus 1 centimeter. So that's where uncertainty can really help us. We don't need to get exactly 25. As long as we're within 1 centimeter, the allowed uncertainty, that is fine. And I would record this as 881. This is microseconds. Now I need to make okay, so I need to record the tension, which I did already, hopefully. And I need to record this time. So as a note here, there's 881 microseconds. These are pretty small. I've processed the data, so as a tip for you, you probably don't want seconds, but you might want milliseconds. Equals microseconds. And then we could also have milliseconds. Hopefully you know that there are 1,000 milliseconds in 1 second, and there's 1,000 microseconds in 1 millisecond. So for instance, 881 microseconds would be 0.881 milliseconds. I'm going to suggest that milliseconds are a good unit to use for this experiment. You could use microseconds, but milliseconds will probably give you the best results. Do this twice more. So this would be 881. I would do this again. And this one was 910. So I would just call that 910. And I would do it once more. Not good enough. Do it once more. Barely good enough. 920. Now the interesting thing here is, again, it doesn't let me keep my zeros. Remember these buttons over here, you can press them to get the right number of decimal places to control them. When you do your averaging things, you're probably going to get lots of decimal places. So again, having a consistent number of decimal places is a good idea. Hopefully this helps, and if you have any questions, ask your teacher.